Hello everyone, my name is Sethi. I hope you all are staying healthy. Today we are going to talk about input-output model with a numerical question. Input-output model is given by Wesley Leontief, that's why also known as Leontief model. This model explains interdependency among industries. That means industries are depend on each other. As we know, we use output of one industry as an input for another industry. For example, wheat is the final output for agriculture sector, but we use wheat as a input for food processing industry. So we can say that we use output of one industry as an input for another industry. That's why industries are depend on each other. Here X represent industries, Ij represent, we are using output of I industry as an input for J industry. I industry is coal industry and coal is final output for coal industry. J is a steel industry and steel industry using coal as a input. So we can say that Ij represent, we are using output of I industry as an input for J industry. Now it's the input output table. Here we have four industries X1, X2, X3, X4. Here is also written X1, X2, X3 and X4. Here input written because these column represent input of industries. Here is output written because this row represent total output of industry. Xij means Ij represent output of I industries input for J industry. So X11 represent output of first industry is input for first industry. Sometime industry use their own output as an input. For example, sometimes steel industry uses steel as an input for further production. 1-2 represent output of first industry is input for second industry. 1-3 represent output of first industry is input for a third industry. 1-4 represent output of first industry is input for fourth industry. Similar, 2-1 represent output of second industry is input for first industry. Similar, you can see other cases. X32 represent output of third industry is input for second industry. X43 represent output of fourth industry is input for third industry. L1, L2, L3, L4 represent labor. L1 labor belongs to X1, L2 belongs to X2, L3 belongs to X3 and L4 labor belongs to X4 industry. Here we have final demand. F1 demand belongs to X1. F2 demand belongs to X2. Similar, you can see F3 and F4 belongs to X3 and X4. Now we'll see how to calculate cost and revenue of industries. First industry using their own output, through this process it will earn some income. Second industry using output of first industry. When second industry using output of first industry, obviously in return second industry will pay some money to first industry. Obviously it will called income of first industry. Similar, this one also income of first industry and this is final demand of first industry. When we add all these, it will become equal to revenue, or you can say total output of first industry. This is total cost of first industry. First industry hire labor, in return it will pay wages to labor. Wages are cost of industry. First industry using output of fourth industry. First industry using output of fourth industry. Then obviously in return first industry will pay some money to fourth industry. If first industry paying money to fourth industry, it will be called cost of first industry. Similar, this one also called cost of first industry. This part will be called cost of first industry. When we add all these, it will be called cost of first industry. Similar, this will be called revenue of second industry and this will be called cost of second industry. Similar, this is revenue of a third industry and this is cost of third industry and this is revenue of fourth industry and this is cost of a fourth industry. So by this way you can calculate cost and revenue of all industries. Now we will solve one question. We have two industries, industry 1 and industry 2. This side means row represent output and column represent input. we have to find out gross output for each industry for the final demand 100 and 200 respectively. First step, we will calculate technical coefficient matrix. Means in first step, we will calculate A. In order to calculate A, we divide 125 with this final output. You can see here. We will also divide 62.50 with this final output. And here we divide 87.50 with this one output and 29.17 with this one output. When we divide means when we solve, this one become equal to 0.4, this one 0.3, this one 0.2 and this one 0.1, and this will be called our technical coefficient matrix, means this will be called our A. So this is our A. In second step, we will calculate Leontief matrix. This is formula to calculate Leontief matrix I minus A. Here I represent identity matrix. So this is 2 by 2 identity matrix and this is our A. So I minus A. 1 minus 0.4 equal to 0.6, 0 minus 0.3 minus 0.3, 0 minus 0.2 minus 0.2. Similar, 1 minus 0.1 equal to 0.9. In third step, we will find determinant of I minus A. This is our I minus A. We will find its determinant. In order to find determinant, we will cross multiply. So 0.6 into 0.9, 0.6 into 0.9 minus 0.3 into 0.2, 0.3 into 0.2. When we solve, it will become equal to 0.48. 0.48 will be called determinant of I minus A. So this is our determinant of I minus A. Determinant is 0.48 and 0.48 is greater than 0. Determinant greater than 0 shows system can produce enough to meet internal and external final demand. In short, our solution exists. Without any doubt, we can proceed further. So in next step, we will find out inverse of I minus A. As we know, inverse of 2 by 2 matrix equal to 1 over determinant. This is our determinant. 1 over determinant D minus B C minus CA. That means in place of D, we will write A, and in place of A, we will write D. So this is our I minus A. In place of A, we will write D. So here you write D, and in place of D, you will write A. So here you can see 0.6 is written. And with the B, we will apply this minus sign. Here already minus sign, both will cancel out. So it will become equal to 0.3. With the C, we also apply minus sign, already minus sign. So it will become equal to 0.2, and this is our determinant, 1 over determinant, and this one we write here. So this is our formula to find out gross output. We have already calculated this part, and this part is equal to this one we have already calculated. So here is written, and D is a final demand vector which is already given in question. We have to find out gross output for 100 and 200 final demand respectively. So in place of D, here is written 100 and 200. Now we will solve. Means we will multiply each other. 0.9 multiply with 100, 0.2 multiply with 100 plus 0.3 multiply with 200 plus 0.6 multiply with 200. When we solve, it will become equal to this. So this is our final solution. 150 divided by 0.48 become equal to this one. 140 also divided by 0.48 become equal to this one. So we can say that in order to meet final demand of 100 and 200 unit, gross output must be produced 312.5 and 291.67. So this is all about today's video. I think you got it, and thank you so much for watching this video. Bye. Take care.